यस, गुड मॉर्निंग एवरीवन। लास्ट टाइम हमने थ्योरम पढ़ी थी कि इफ़ अ फंक्शन बी डिफाइंड इन अ डोमेन D and uxy and vxy have continuous partials that satisfy the CR equations for all points in D, then function is analytic in D. अब इसका कन्वर्स पार्ट लिख रही हूँ. A function is analytic in a domain D if and only if the function has continuous partials that satisfy the CR equations for all points in D, right? इसके आगे कुछ रिमार्क्स हैं, that is curly u over curly x 0 0, that is at the origin, which is equal to limit x tends to 0 ux 0 minus u 0 0 over x, curly u over curly y, if with respect to y differentiate करें हैं, then limit y tends to 0 u 0 y. Now you are taking the y coordinate, so you write 0 y minus u 0 0 over y. Similarly, the result for curly v over curly x and curly v over curly y, just write v instead of u. The fifth remark is every polynomial is an entire function, that is, entire function means it is continuous and differentiable everywhere. The other examples are sin z and cos z. Okay, next page. Now there is a question, that is, some are the exercises that is based on the CR equations and analyticity of the function. So the first exercise is show that the function root mod of xy is not analytic at the origin, although CR equations are satisfied at that point. Now your function is fz is equal to u plus iota v, which is further root of mod xy. Now the equating real and imaginary parts, your u is root of mod xy. Since there is no imaginary part, so v is 0. Clear? If v is 0, then we know that curly v over curly x is 0 and curly v over curly y is also 0, because differentiation of a 0 is, if you open this curly v over curly x with respect to that formula जो अभी हमने आपको बताया था पीछे, उसके रिस्पेक्ट में इसका आंसर 0 है. Now u का देखते हैं. u is this, what is curly u over curly x? This is equal to limit x tends to 0, at the origin you are taking x tends to 0, this is ux comma 0 minus u 0 0 over x. Putting y equal to 0 in your u, that is y is 0, then this whole thing is 0, so this part is 0. u 0 0 is also 0. If x and y both are 0, then this u will become 0 over x. So this is 0. Limit x tends to 0. This comes up to be 0. Similarly, what is curly u over curly y at the origin? This is limit y tends to 0 u 0 comma y minus u 0 0 over y. Limit y tends to 0, this is putting x equal to 0 over here, you will get it as 0 minus u00 is also 0 over y. Final comes out to be 0. So the CR equations are satisfied. What are the CR equations? That is curly u over curly x is equal to curly v over curly x. This is 0 and curly v over curly x is also 0. The other equation is curly u over curly y is negative of curly v over curly, sorry, this is y. अगर हम यहाँ पर x लिखते हैं तो v के साथ y आता है और अगर हम y लिखते हैं तो v के साथ x आता है. So both the equations are satisfied. So the CR equations are satisfied at the origin. CR equations are satisfied at the origin. Now let's check about the analyticity. That is, we are to check that the function is differentiable or not at the origin. Now if this is origin, when the function will be analytic at this origin, if it is differentiable at everywhere in the neighborhood of 0. If the function is differentiable at all the points or everywhere in the neighborhood of the origin, then the function is analytic at the origin. So I'm letting z tends to 0 along the line y equal to x. If my function is not differentiable along y equal to x, then the function is not differentiable about this point. So the function is not differentiable everywhere in the neighborhood of the origin. So the function is not analytic at the origin. अगर वो इस लाइन पर ही differentiable नहीं होगा, that means फिर neighborhood के सारे points पर तो ये differentiable नहीं है. That means वो function क्या है, 0 पर analytic नहीं है. So I'm letting z tends to 0 along y equal to x just to check about this line whether the function is differentiable or not. So letting z tends to 0 about along y equal to x, we get limit z tends to 0 fz minus f0 over z, that is limit z tends to 0. What is fz? This is root of mod xy over what is z? This is x plus iota y. Putting y equal to x, I will be get, now I am writing instead of z as x because my whole expression is in x. So this is mod x square over x plus iota x. Further it is equal to limit x tends to 0. This is under root of x square over x 1 plus iota. Since the mod is positive, so I'm writing x square only. Further, limit z tends x tends to 0. What is root of x square? This we know that mod x is equal to root of x square. So instead of root of x square, I am using mod x over x 1 plus iota. Now checking the right hand limit first. This is mod x over x. I'm skipping this for some time. So this is if x tends to 0 positive, then mod is also positive. This comes out to be 1. The left hand limit, x tends to 0 negative, mod is over x, that is equal to minus x over x, which is equal to minus 1. since both the right hand limit and left hand limit both are not equal, so the function is not differentiable. Hence the limit does not exist. Both the limits are unequal, so limit x tends to 0 mod x over x does not exist. Or now you may write 1 plus iota also. Just I have skipping this. Thus limit z tends to 0 f of z minus f0 over z does not exist. If the limit does not exist, the function is not differentiable. Fz is not differentiable at z equal to 0, so the function is not analytic at z equal to 0. Hence the result. Next, show that fz equal to e raised to power minus z raised to the power minus 4 and f0 equal to 0 is given is not analytic at z equal to 0. Although CR equations are satisfied at the point. This question is very important. Also pretty lengthy. So जस्ट इसको वैसे ही करना है जैसे हमने पिछले वाला क्वेश्चन किया है. So take fz equal to u plus iota v that is equal to e raised to the power minus z minus 4. This is e raised to the power, what is x? This is, sorry, what is z? It is x plus iota y the power minus 4. Further, you can also write it as e raised to the power minus 1 over x plus iota y the power 4. Now e raised to the power minus 1 over x plus iota the power 4. I am rationalizing this. On rationalizing, I will be getting x minus iota y the power 4 and x minus iota y the power 4. This is equal to e raised to the power minus x minus iota y the power 4 over, this is x square plus y square the power 4. Now if you open this on about that formula, that is a minus b raised to the power 4, and equating the real and imaginary parts, you will get, just solve this on your own, you will get e raised to the power minus x4 plus y4 minus 6x square y square over x square plus y square the power 4 into e raised to the power iota 4xy x square minus y square over x square plus y square the power 4. This is e raised to the power minus x4 plus y4 minus 6x square y square over x square plus y square the power 4. Using the Euler's formula, you will get cos of 4xy into x square y minus y square over x square plus y square the power 4 plus iota times sine of the same function. Now again, equating the real and imaginary part, you will get your u as this and v as first expression into the second one. So your u comes out to be e raised to the power minus x4 plus y4 minus 6x square y square over x square plus y square the power 4 into cos of 4xy x square minus y square the power divide by x square plus y square the power 4. And your v comes out to be same this expression, x square plus y square minus 6x square y square over x square plus y square the power 4 into sine of 4xy into x square minus y square over x square plus y square the power 4. Now y as your function at the origin is 0. Now checking the CR equations. What is curly u over curly x at the origin? This is limit x tends to 0 u x0 minus u0 0 over x, which is equal to limit x tends to 0. यहाँ पर y coordinate 0 कर दीजिए. You will be getting e raised to the power minus x raised to the power 4 over x raised to the power 6. और y यहाँ पर 0 हो जाएगा तो cos 0 is 1. So this is limit x tends to 0. Sorry, divide by x raised to the power 6. Divide by x also. 1 over x. So this comes out to be e raised to the power minus this is 1 over x square over x. This is limit x tends to 0 1 over x into e raised to power 1 over x square. You can also write इसको denominator में ले जाइए. So opening the formula for e the power x. What is that? What is e the power x? This is 1 plus x over 1 factorial plus x square over 2 factorial up to so on. So your x is 1 over x square. So opening this 1 plus 1 over x square plus 1 over x4 into 2 factorial up to so on. So taking x inside, you will be getting x plus 1 over x plus up to so on. Now ये जो सेकेंड थर्ड सारी टर्म्स जो आपकी क्योंकि x 0 है तो इन्फिनिटी हो जाएंगे और ये टर्म 0 है तो 0 प्लस इन्फिनिटी. सो दिस इज 1 over infinity which is equal to 0. Okay. Similarly, curly u over curly y. This is limit y tends to 0 u0 y minus u0 0 over y. This is also comes out to be 0. बिल्कुल वैसे ही करना है, सेम रिजल्ट है. Now curly v over curly x at the origin, ये भी आपका 0 आ जाएगा. And curly v over curly y at the origin, similarly ये सब आपके 0 आ जाएंगे. Hence CR equations are satisfied at the origin. Clear? Now अब हम अपनी डिफरेंशिएबिलिटी चेक करेंगे along y equal to x. Limit z tends to 0 f of z minus f of 0 over z. This is equal to limit z tends to 0 e raised to the power minus z the power minus 4 over z. अब यहाँ पर देखो आप this is the origin, this is y equal to x. What is this theta if y is equal to x along this? This theta is pi by 4. We all know that. And this r is positive. ठीक है, अगर आपकी अलॉन्ग y इक्वल टू x, क्योंकि मिड लाइन होती है तो वहाँ पर ये 90 डिग्री का एंगल है, तो उसका हाफ यहाँ पर एंगल आपका pi by 4 होगा. So letting z tends to 0 along, I'm not writing y equal to x, I'm writing in polar form. Z is equal to r e raised to the power iota. What is theta? This is pi by 4, where r is positive. So the limit z tends to 0. This is e raised to the power minus r e raised to the power iota pi by 4. उसकी भी आगे पावर -4 over r e raised to the power iota pi by 4. This is equal to 1 over e pi iota by 4. लिमिट, अब यहाँ पर लिमिट लगेगी r टेंस टू 0 पॉजिटिव. 0 पॉजिटिव इसलिए बिकॉज r हमारा पॉजिटिव है. It is greater than 0. So this is e raised to the power minus r raised to the power minus 4 into e raised to the power minus pi iota. Now this e raised to the power minus pi iota is -1. If you open this using the Euler's formula, you will get cos of pi minus pi plus iota sine of minus pi. So this is cos of pi minus iota sine of pi. I am writing again. Euler's formula के हिसाब से this is equal to cos of pi minus, because यहाँ पर नेगेटिव है, minus iota sine of pi. So cos of pi is -1 and sine of pi is 0. So this term is -1. So limit, this implies z tends to 0. 1 over e raised to the power pi iota by 4. Limit r tends to 0 positive. E raised to the power minus r raised to the power minus 4 into -1. So this is positive. Further, limit z tends to 0. 1 over e raised to the power pi iota by 4. Limit r tends to 0 positive. E raised to the power राइट. इसको हम 1 over r दी पावर 4 भी लिख सकते हैं. नेक्स्ट पेज पे लिखते हैं. वेट, यहीं पे करते हैं. सो दिस इज लिमिट z टेंस टू 0. 1 over e raised to the power pi iota by 4 into limit r tends to 0 positive. Wait. ये हमने नहीं लिखना है. बिकॉज यहाँ पर लिमिट r की चल रही है. ठीक है. e raised to the power 1 by r की power 4. Now 1 by 0, if I put the limit r 0 as this is 1 by 0, which is infinity, and e the power infinity is also infinity, and this is also infinity, 1 by r. कहाँ पर है, ये 1/r भी चल रहा है. This is also in wait. Infinity into infinity. This is equal to infinity. So the limit does not limit does not exist finitely. So fz is not differentiable at z equal to 0. So fz is not differentiable at z equal to 0. Hence, function is not analytic at z equal to 0. राइट, बिकॉज हमारी लिमिट फाइनाइटली नहीं आई है, दैट मीन्स फंक्शन डिफरेंशिएबल नहीं है. उसके लिए हमारी लिमिट फाइनाइट आनी चाहिए थी. सो द नेक्स्ट क्वेश्चन इज एग्जामिन द नेचर ऑफ द फंक्शन एफ जेड इन अ रीजन इंक्लूडिंग द ओरिजिन. नेचर मीन्स आपको यहाँ पर इस फंक्शन की एनालिटिसिटी चेक करनी है भी है या नहीं है. ठीक है. सो द सॉल्यूशन again, fz is equal to u plus iota v, which is equal to x square by the power 5 x plus iota y over x4 plus y raised to the power 10. You find now your f0 is 0 as f of 0 is 0. Then wait, what is your u and v? You equate the real and imaginary parts. Your u is equal to x square y raised to the power 5 over x4 plus y raised to the power 10 y raised to the power 10 into this is x, which is equal to x cube y raised to the power 5 over x4 plus y raised to the power 10. This is your u. And what is your v? V comes out to be x square y raised to the power 6 over x4 plus y raised to the power 10. Now find your curly u over curly x at the origin. This comes out to be 0. You find this on your own. And your curly u over curly y at the origin is also 0. Similarly, curly v over curly x at the origin is 0, and curly v over curly y at the origin also comes out to be 0. Hence, CR equations are satisfied at the origin. Right? So, if CR equations are satisfied, now checking the differentiability. Okay. Limit z tends to 0 f of z minus f of 0 over z. This is equal to limit z tends to 0. Your function is x square y raised to the power 5 x plus iota y over x4 plus y raised to the power 10 into what is z? This is x plus iota y. ये वाला z. ठीक है. अब x प्लस आइटा y तो कैंसिल हो गए आपस में. सो दिस इज लिमिट x y टेंड्स टू 0 0. दिस इज x स्क्वायर y रेज टू द पावर 5 ओवर x4 प्लस y रेज टू द पावर 10. नाउ लेटिंग z इक्वल टू 0 अलोंग. अब आपकी एनालिटिसिटी चेक करनी है. हम यहाँ पर अब कोई भी रूट ले सकते हैं. लेटिंग z tends to 0 along. मुझे ऐसे लेना कि हमारे जो है x जो हमारा जो x है वो हमारा ख़त्म हो जाए. ठीक है, जैसे हमने पहले किया था. तो अगर हम y रेज टू द पावर 5 को, क्योंकि यहाँ पर x स्क्वायर और यहाँ पर 4 है, मुझे पावर सेम करनी है, तो मैं y रेज टू द पावर 5 को m x स्क्वायर लूँगी. बिकॉज x स्क्वायर लेने से मेरी पावर जो है सेम हो जाएगी डिनोमिनेटर वाली. So y raised to the power 5 is mx square. So this is limit xy tends to 0 0 यहाँ पर एक्स स्क्वायर इंटू एम एक्स स्क्वायर ओवर x4 प्लस एम, दिस इज़ वाई द पावर 10, वाई द पावर 5 जो है वो एम स्क्वायर और यहाँ पर x4 हो जाएगा. ठीक है. अब यहाँ पर लिमिट आपको खाली x टेंस टू 0 लेनी है, बिकॉज हमारा एक्सप्रेशन सारा x में आ गया. सो दिस इज इक्वल टू लिमिट x टेंस टू 0, कॉमन लेंगे, दिस इज m ओवर 1 प्लस m स्क्वायर, ओके, which will be different for different values of m. This limit is different for different values of m. Hence, since therefore limit z tends to 0, fz minus f0 over z does not exist. So the function is, क्या हुआ nature function का? It is not analytic. fz is not differentiable at z equal to 0, hence thus fz is not analytic at z equal to 0. Okay, one more question. Show that fz equal to xy plus iota y is everywhere continuous but is not analytic. जो हमने आपको फर्स्टली रिमार्क्स दिए थे वहाँ पर हमने बोला था कि एवरी पॉलिनोमियल इज़ अ एंटायर फंक्शन. तो अगर ये आपका fz पॉलिनोमियल है, दिस इज़ एंटायर फंक्शन, सो दिस इज़ कॉन्टिन्यूस एंड ऑल्सो डिफरेंशिएबल एवरीवेयर. सो ये फर्स्ट चीज़ तो यहीं से प्रूव होगी, दिस इज़ एवरीवेयर, दिस फंक्शन इज़ एवरीवेयर कॉन्टिन्यूस बिकॉज द फंक्शन इज़ अ पॉलिनोमियल. नाउ लेट your f of z is equal to u plus iota v, which is equal to xy plus iota y. Then your u is xy and v is y. This is also polynomial, this is also polynomial. Since u and v are polynomials in x and y, ये फर्स्ट चीज़ मैं प्रूव कर रही हूँ. Therefore u and v are continuous everywhere. Continuous everywhere फर्स्ट चीज़ हमारी प्रूव होगी. Thus f of z is continuous. ठीक हो गया. नाउ अब हम इसके एनालिटिसिटी की बात करते हैं. चेकिंग द CR इक्वेशंस. व्हाट इज कर्ली u ओवर कर्ली x? दिस इज y. एंड व्हाट इज कर्ली v ओवर कर्ली y? दिस इज 1. ओके. नाउ व्हाट इज कर्ली u ओवर कर्ली y? This is x and curly v over curly x is 0. CR equations are not satisfied. CR equations क्या है? curly u over curly x आपका curly v over curly y के इक्वल होना चाहिए and curly u over curly y is equal to minus curly v over curly x. So the CR equations are not satisfied. अब CR इक्वेशन ही सेटिस्फाइड नहीं है तो फंक्शन इज नॉट एनालिटिक. Thus fz function is not analytic. fz is not analytic. Okay, fine. कुछ और क्वेश्चंस हैं जो हम इस नेक्स्ट टाइम हम पढ़ेंगे. वो फंक्शन के कांस्टेंट, फंक्शन आपका कांस्टेंट है या नहीं, उसके फंक्शन के कांस्टेंट जो है इन डोमेन, यू हैव टू प्रूव दैट fz इज़ कांस्टेंट और नॉट इन अ डोमेन. उसके बेस पर हम आगे क्वेश्चंस करेंगे. सो दिस लास्ट क्वेश्चन, दिस इज़ एन एक्सरसाइज फॉर यू. जस्ट यू प्रूव in this question you are having the function sin x cos hyperbolic y cos x sin hyperbolic y. This is continuous. Why? Because u is this. Since the sin z and cos z, ये सारे के सारे जो trigonometric functions है, these are all continuous everywhere because these are the entire functions. मैंने आपको first note पर ही remark में बताया था, तो वहाँ से आप बताएंगे u and v are continuous everywhere as sin and cos, these functions are entire functions. And your second part is, okay, I will write this. Let f of z is equal to u plus iota v. Now what is u? This is sin of x cos hyperbolic y. What is v? This is cos of x sin hyperbolic y. Both the functions are continuous, hence the function is continuous. ये तो हो गया first part. Second, your Cauchy equations. What is curly u over curly x? You find this, and curly u over curly y, ये भी find out कीजिए, and curly v over curly x, curly v over curly y, ये सभी find out कीजिए. Your Cauchy Riemann equations will be satisfied. So वहाँ पर CR equations जो आपकी satisfy हो जाएंगी. So the function is analytic everywhere. The function is analytic everywhere. Okay. Do you know the derivative for the hyperbolic functions? Derivative of sin hyperbolic y is, this is your hint, this is cos hyperbolic y. Okay, and the derivative for cos hyperbolic y is also sin hyperbolic y. हाइपरबोलिक फंक्शन में प्लस माइनस का कोई चक्कर नहीं है, तो इनका डेरिवेटिव इसको यूज़ कीजिए और ये सॉल्व कीजिए. आपके ये जो है पार्शियल्स जो है आप निकालिए, तो CR इक्वेशंस आपके सेटिस्फाई हो जाएंगी. सो नेक्स्ट टाइम हम क्वेश्चंस करेंगे फंक्शन आपका कांस्टेंट है या नहीं डोमेन में, उसके बेस पे क्वेश्चंस करेंगे. कुछ हम लिमिट्स भी सॉल्व करेंगे, उसके बाद हम हार्मोनिक फंक्शंस पर चलेंगे. ओके, सो थैंक यू वेरी मच.